Good morning, Algebra 2. We are going to be doing Lesson 104. Now, Lesson 104 is on transformations, and that's when our parent function has been transformed. So it's either been moved to the left or to the right, or it's been reflected. And you might think, like, when does this happen in real life? Well, when you play a video game and Mario is moving, those are transformations. He's moving to the right, he's jumping up, he's moving down. And so there's these functions or these equations happening behind the scenes. So I have written down what's on page 725. And so there's different kinds of transformations. A vertical shift is when a graph moves up or down, as you can see here, but the number is going to be outside of the function or outside of the parentheses. Okay, it's not going to be near x. It's going to be on the outside. If k is, and I'm using a different letter than your book. I don't like that the book chose the same letter, and different books use different letters. So anyways, if k is positive or greater than 0, it'll shift the graph up. If k is less than 0, it'll shift the graph down. The next type of transformation is horizontal. So notice the difference. Your h is inside, near x. And that's how I tell the difference between a vertical shift and a horizontal. If it is near the x, it's affecting your x, which runs left to right. If h is less than 0, now I want you to picture this. If I have x and h is less than 0, the standard form is x minus, and so a negative h would actually make this appear as x plus h. So you might see x plus h, but know that that came from a negative value, and that's why it's shifting to the left. It shifts to the right, because if I plug in a positive h value, I would get x minus h. So you have to consider the standard form it was in. Then there are reflections. So a reflection across the x-axis would mean that it would go from pointing up to pointing down. Across the y-axis would mean that it would be like a graph pointing to the right with all of a sudden point to the left. And so your x-axis shifts it from like up, down. The across y-axis, left, right. Notice the difference. The negative on the outside affects our y values. That's why it's flipping vertically. And the x, if the negative is on the inside, then it's a horizontal. Last is, sorry, and I didn't highlight that. There you go. And then finally is a stretch, and there should actually be a line here, or compress. And that is when the graph is either made to appear more skinny or more wide. We covered this when we did parabolas. So this is on the outside of your equation. If a is greater than 0, it stretches it. If a is less than 0, it compresses it. So there is quite a bit in our lesson practice today, so I wanted to do 2 examples with you before we got there. So if I have this function, g of x equals the square root of x minus 3 plus 2. The square root of x is my parent function. Negative 3 is a shift to the right, 3, and that's based on what I have up here. If it is x minus h, I have it right here, it's shift to the right. And then the plus 2, because this is h, this plus 2, it represents k, and so this is up 2, okay? So this is k, this is h. All right, so I'm now going to, I realize that you guys are going to use Desmos, but I want to show you how I would have taught it if you guys were like actually in person. So the square root of x. I cannot take the square root of negative numbers. So the smallest number I could plug in is 0, and the square root of 0 is 0. If I plug in 1, the square root of 1 is 1. Now I like to do numbers that create whole answers. So 4, because the square root of 4 is 2. And 9, because the square root of 9 is 3. Now you don't have to use all of those, but it does give us a good start. So I'm going to draw my x and y axes. Sorry, I went quiet for a little bit, sorry. 2, 4, 6, 2, 4, 6. And I'm going to plot my parent function in pencil. So 0, 0, 1, 1, 4, 2. Right here's my parent function. This is y equals the square root of x. But this is the function they wanted me to graph. So I'm going to take these points and I'm going to transform them. So I'm going to take this and I'm going to move it right 3 and up 2. So to the right 3, up 2. There's our very first point. Next point, right 3, up 2. Next point, right 3, up 2. And I'm not going to bother, well, I mean, I guess you could write 3, up 2. And so now, here is my graph. Okay, so I used my parent function and then I transformed it. Now, if you obviously could check your work by going to Desmos and entering y equals the square root of x minus 3 and then out here plus 2. Okay, and you could verify our points. Number 2, I have a negative out here, so this is a reflection according to our table across the x-axis. And this here would be, now notice it's not inside the square root, it's on the outside. So this is inside near x, so this is outside. So this would be a shift either up or down, but because it's negative or less than 0, it's a shift down 2. So again, I'm going to draw my parent function. So 2, 4, 6, 8, 2, 4, 2. Okay, and I'm using the same table. So same equation. So 0, 0, 1, 1, 4, 2. Let's say I just do those points right there. Now I'm going to transform it by using these transformations. So I'm going to start with this point here because I think it's easier. A reflection would put it here, right? This is the x-axis. And so it's 2 units away, so I would go 2 in the opposite direction, but then it says down 2, so 1, 2. This point here would be reflected, it's 1 unit across, so a reflection would put it here, but then I'm going down 2. This point, if I reflected it, it's on the x-axis, so it wouldn't go anywhere, but I'm moving it down 2. So my graph would look like this. Okay, so I'd like us to now try the ones in our lesson practice. And so let me turn my page. Part, I should probably draw on the backs of these. So part A wants us to graph h of x equals the square root of x plus 10. Now notice where that plus 10 is. It's not inside near x, it's on the outside. So this graph has been shifted up 10 units. And it's still using the square root of x function. So if I do x, y equals the square root of x, I've got 0, 0, 1, 1, 4, 2. So I'm going to change my scale because otherwise I have a really large graph. So if I do 10, 8, 6, 4, that's wrong. 2, 4, yeah, sorry. 10, 6, 2, here would be 0. And so I'm going to have to go by 2, 4. Okay, so I changed my scale. Here's my x-axis, here's y. So I'm going to graph this parent function, 0, 0. This would be 1, 1, and I probably should have adjusted. I should have made this on the same scale to make this less confusing for you guys. And I'm going to go ahead and put 9, 3. Okay, so my bad. I'm going to go ahead and go by the same scale, 2, 6, 10. 2, 4, 6, 8. I'm going by twos. So 0, 0, 1, 1, 4, 2, here's 9, 3, right? Here's my graph. But I'm shifting each of these points up 10. So this point at 0, 0 goes up 10. This point's going to go up 10. Okay, so this is 2, 4, 6, 2, 4, 6, 8, 10. 1, 3, 5, 7, 9, 10. And so there is our graph. Part B is the h of x is the square root of x minus 1. And so because this is on the inside, h is a positive 1. So I can say that it's been transformed to the right 1 unit. Okay, so really easy graph because I'm using those same points over and over. 2, 4, 2, 4. I don't need to change anything about this one. So my parent function is 0, 0, 1, 1, 4, 2, 9, 3. And I'm shifting each point to the right 1. And that was it. And this should be a little. And so there is our graph. C, they'd like us to graph h of x equals a negative square root of x. So really simple here. In fact, they're doing a lot easier ones than I did. So 2, negative 2, 2, 4, 6. So parent function, the square root of 0 is 0. Square root of 1 is 1. Square root of 4 is 2. But we are reflecting this across x. So this is a reflection across my x-axis. Here's x. So I'm going over x. So it's 2 units away, so 2 below. 1 unit, so 1 below. This point is on the x-axis, so it doesn't move. And so our graph is in blue. Next page. Part D. We're going to graph h of x equals 4 times x. Now this is a stretch by 4, meaning we're going to multiply the y value by 4. And whenever in doubt, you can build a table. But I'm showing you how to do it a little bit more professional. Okay? So I'm going to go, let's see here, 12, 10, 8, 6, 4, 2, here's 0. 2, 4, 6, 8, 10. X, here's y. So let's graph that parent function again. 0, 0, 1, 1, 4, 2, 9, 3. And so here's my original function that I just keep transforming. Now, if you want to see this as a table, so if I plugged in, this is x and this is 8. If I plug in 0, the square root of 0 is 0. 0 times 4 is 0. So this point doesn't change. But if I plug in 1, the square root of 1 is 1 times 4 is now 4. Okay, the square root of 4, if I plug that in, is 2, but 2 times 4, this is now at 8. You can hardly see the pencil, and I apologize. If I plug in the square root of 9, square root of 9 is 3, but 3 times 4 is 12. And so these y values are what's changing. This is still at 0, but the square root of 1 is 1 times 4. This is now way up here. This point here, 2 times 4 is 8, and this point here is all the way up at 12. And so my graph has been stretched vertically. So check that out. Crazy. Each y value has been, and I'll show a little table here. When in doubt, build a table. 0, 0, 1, 4, 4, 8, 9, 12. All right, part E. E, they'd like us to graph h of x. And I'm actually going to have us doing a lot. Equals 1/5 2 minus x. All right, so first of all, I'm going to rewrite this order. So 1/5, and then I'm going to put negative x. I'm going to rewrite it so it's in order. And I'm also going to make this the decimal, which is 0.2, sorry, because I think that's easier. Now, I need to separate the two transformations inside. So I'm going to factor out a -1, which leaves me with x minus 2. And now I'm going to label, this is a compression. So I'm going to multiply by 0.2. This is a reflection across y. Whoops. And this is right 2. And so we have a lot that we are going to be doing, but again, when in doubt, I could build a table. So we could use the same numbers, that we usually use, and we could just plug them into this equation. So that is an option. Let's see if we get the same answers by just transforming. Now, compression is going to have the opposite effect. Instead of stretching them up, our graph's actually going to be compressed down. So 2, 4, 6, 8, 10, 2, 4, -2, -4, -6. All right, so let's draw our parent function, 0, 0, 1, 1, 4, 2, 9, 3. Okay, so I'm going to start with, I think what's easiest is maybe our reflection. So if I reflect this, this is 9 units away. So I would go 9 units to the left. But then I'm going to end up going right 2. And then I'm going to be compressed by 0.2. So if I'm at 3 times 0.2, so I'm now at 0.6. Now, we could check our work. So at 9, let's plug it in and see if we get close to 0.6. So 0.2 times the square root of, I'm going to enter this, 2 minus 9. Whoops. I had to do it the other way, sorry. -1 times 9 plus 2. What is with my calculator lately? -1. Why is it giving me I? Oh, because this should be -9 minus 2. Sorry, I entered. What? Oh, because if I reflect it, sorry, I'm on the negative side. So if I enter negatives, my bad, I would still get the value. So sorry, I'm doing it by hand. If I reflect it, it's 4 away, go 4 to the left, then to the right, 2, and then I have to cut that by 0.2. So 4 times 0.2, this point is now at 0.2. 8. That doesn't make any sense. Oh, because I multiplied it. It should be 0.4. And then this point here, I'm going to reflect it, move it to the right 2, but it's at 1, and 1 times 0.2 is 0.2. And this point here is just to the right 2. And so here is my graph. It has been, the table is going to be too confusing because you're going to have to change, or you can enter this in Desmos. But I think it's easier to do it using reflections. All right, we're going to do one more because it's a different graph, and then we will be done. So for F, it has us using 5 to the x, and they'd like us to graph 5 to the x minus 4. And so I have a new parent function. So 5 to the x, if I do a parent function, 5 squared is 25. 5 to the first is 5. 5 to the 0 is 1. This is 1/5, and this is 1/25. Now, this is a shift down 4 because it's not next to x, it's on the outside. And so, again, you can confirm this in Desmos, but I'm going to try and graph this if I have enough space. So 2, 4, 6. 2, 4, -2, -4. So my parent function would be at -1 is 1/5, 0, 1, 1, 5. It's really all I have room for. This is an exponential graph. But this graph is being shifted down 4. So 2, 4, 2, 4, 2, 4. And so my graph should look like this. For homework, sorry for any confusion, we are going to skip numbers 6, 7, 11, 14, 18, and 30. Thank you.